my favorite expression on this podcast. Back in the day,
Okay.
right? Newton said, well, he didn't say explicitly, but his take on physics was that physics is all about finding forces, right? It's finding the forces that act on objects, and those forces will give us the motion of objects through time. So, you determine the forces, those will give you the accelerations, the velocities,
the momentums, the positions,
over
the
time,
whole thing.
and you will get a description of what's going on physically. But after Einstein showed up and he found that space and time were interlaced, right? They're dynamic. One is not separate from the other, but instead it's this four-dimensional grid that you can, place events on.
Manifold.
Right? Depending on the space-time coordinates, which sounds really fancy, but if you're not like a physics person and you hear, space-time coordinates, it's not that complicated. It's just, you have your spatial coordinates, which is, let's say, okay, 1 meter over here, 1 meter over here, whatever. You have your space coordinate and your time coordinate. Time equals 1 hour, right? There's your space-time coordinate. This
very
position
example,
at this time. Yeah. And then to see how your coordinates evolve, you just have to see where am I versus where I started, and also, how much time has passed.
Time elapsed, exactly.
Which is like the reason why it's such a groundbreaking idea that space and time are together as one, is because as you move in space, you change the experience of time. I guess that's not very
maybe you would want to explain
accurate.
That a bit.
Yeah.
What do you mean your experience of time? Are you just trying to say that your time changes?
Well, I mean the fundamental
experience?
idea is that the speed of light is constant for all observers.
True.
And so to keep that fact, and you start to study velocities or relative velocities and accelerations and all that, you see that for that fact to hold, you need your time to slow down, or
as your speed increases,
your distance to stretch or whatever. And so you see that the fact that you are moving at a certain speed relative to something else will affect your spatial description.
That's what you mean. Okay.
Yeah. So basically, I'm just saying one affects the other, essentially.
Basically, space affects time and the other way around as well.
Yeah.
Like time dilation is a fantastic example.
Exactly.
Basically, I think what you were trying to say, right?
Mm-hmm.
Like time dilation perfectly shows how your velocity or the speed at which you're moving through this space changes how time works for you, right? Like that can be thought of as an idea, right?
Once again, we did talk about this in our special relativity episode.
Yeah.
We are coming out with a part 2 to that, which
part
is
3. Isn't it part
2?
Three?
No, we did a part 2 of quantum mechanics, but not a part 2 of special relativity.
Sorry. I'm thinking. Yeah, true.
That is coming soon as well. But what I was trying to say with this entire thing, by the way, is that physics became less about the motion of objects through time and became more about finding the deterministic laws of nature, right? It's, we kind of zoomed out a bit because, of course, there are laws that determine the motion of objects as time passes. But once you realize that everything is connected together, physics becomes more about what can we know exactly. And Einstein believed in a deterministic model of the universe, which just means that everything, if I want to be broad here, everything has like a for sure value. As I said earlier, right? That gem that you're looking for exists somewhere, and it is possible to find it. Einstein believed in that, and which is why he opposed quantum mechanics, which we'll get to.
We'll get to for sure.
A couple of minutes.
Yeah.
What I was trying to say, Einstein determinism. Yeah,
that's basically it, right?
That's what I was trying to say. Right?
Yeah.
He realized that finding the deterministic laws of nature, that those laws that can get you to the precise, exact values that are embedded in our universe, is what physics is all about.